What if the plane that changes long-haul travel isn't a big wide-body at all? For years, crossing oceans meant boarding something huge. 747s, A380s, Dreamliners, big planes, big engines, big fuel bills. But now, Airbus and CFM are developing a new kind of single-aisle jet that's smaller and lighter, powered by an open-fan engine that looks like someone skipped the outer shell entirely. If it works, it could use about 20% less fuel while still flying across the Atlantic, meaning your next New York to London flight might not be on a massive jet, but on something the size of a regular A320. So here's the real question: is the age of the giant airliner coming to an end? Wide-body jets were born in a different era, an era of booming travel, cheap fuel, and packed airports. The logic was simple: bigger planes, fewer flights, more passengers per trip. The 747 made it possible to move hundreds of people halfway across the world in one go, but that world doesn't exist anymore. Fuel prices have climbed, air traffic has exploded, and passengers, especially after the pandemic, want direct flights, not long layovers at crowded hubs. The hub and spoke system that wide-bodies were built for is creaking under its own weight. Every time an airline flies a half-empty jumbo across the Atlantic, it bleeds money. The economics just don't add up anymore. A 300-seat aircraft is great when you can fill it, but brutal when you can't. Meanwhile, single-aisle jets like the Airbus A321neo and Boeing 737 MAX have quietly been expanding their range. The A321XLR, for example, can fly almost 5,000 nautical miles, enough to cross the Atlantic comfortably. That means airlines can now connect smaller cities like Edinburgh to Boston or Lisbon to Montreal without relying on huge fuel-hungry jets. And for passengers, it means cheaper fares, fewer layovers, and more routes that feel personal and efficient. The future of flight, it seems, isn't about flying bigger, it's about flying smarter. So what exactly is Airbus building that's scaring the wide-bodies? It's called the CFM RISE program, short for Revolutionary Innovation for Sustainable Engines. It's not just an upgraded A320neo, it's a rethinking of how jet engines should even look. Instead of the usual enclosed turbofan, the RISE uses an open fan design, a set of massive composite blades spinning freely without a casing. Think of it like a propeller evolved for the 21st century. This isn't a gimmick. The design could cut fuel burn by 20% or more, and reduce carbon emissions to levels that make today's jets look wasteful. It's the biggest single leap in propulsion efficiency in decades, but efficiency alone isn't the goal. Airbus wants to give this jet the range and performance of a widebody, but with the simplicity and economics of a narrowbody. We're talking 4,500 to 5,000 nautical miles of range, long enough to connect New York to London or Dubai to Singapore. And in the long run, Airbus envisions hybrid electric assistance. Imagine an aircraft that uses battery power for takeoff, then transitions to jet power at altitude. And CFM has already tested key parts of the open fan on the ground, and Airbus plans to flight test the full setup later this decade. If it works, it could be the most disruptive thing to happen to commercial aviation since the first jet engine. Let's talk about what passengers actually care about. When most people hear narrowbody, they usually picture cramped seats, smaller bins, and less comfort, but the reality is changing fast. Modern single-aisle cabins, especially on the new A321XLR configurations, are surprisingly spacious. For example, JetBlue's A321LR already flies New York to London with full lie-flat business class suites on a single-aisle aircraft. 15 years ago, nobody would have believed that was possible. But the biggest difference you'll notice? The price. If the open fan jet delivers on its promises, airlines could save millions in fuel every year. That means cheaper tickets, especially for long thin routes that used to require wide-bodies. Think non-stops between smaller cities without needing to route through Heathrow or JFK. There will be trade-offs, of course. The open fan's unique design could generate a different noise profile, even with noise reduction tech, and you won't get the grand cabin width of a 777 or A350. But if you're saving between $300 and $500 per ticket and skipping a layover, most travelers will take that deal in a heartbeat. The future cabin may not be wider, but it'll be smarter. If you've made it this far, you're already ahead of most travelers who still think big plane equals long haul. But here's where the story gets even wilder. The economics behind this shift could upend the entire airline industry. Now let's step into the airline CEO's shoes. Every aircraft they buy is a bet on cost, fuel, and passenger demand. Widebodies are expensive to maintain, require longer runways, and can take years to pay off. By contrast, a narrowbody that can fly transatlantic distances changes everything. It lowers the cost per available seat mile, or CASM, dramatically. You only have to fill 180 to 200 seats, not 350. That's easier to do, even in the off-season. It also opens new routes that widebodies can't operate profitably. These are called long thin routes, long in distance but thin in demand. Take JetBlue, for instance. Their A321LR is already flying from Boston to Paris, routes that used to require an A330. TAP Air Portugal connects Lisbon to secondary North American cities in the same way. With a RISE-powered narrowbody, those routes become cheaper and easier to scale. And that has ripple effects. If smaller jets can handle most long-haul routes profitably, airlines might delay or even cancel widebody orders. Why buy a $350 million twin aisle when a $150 million narrowbody can do 90% of the same job? This isn't about replacing airplanes, it's about rewriting the business model of global aviation. But this is where the story shifts, because everything that sounds promising on paper runs into one serious problem. Of course, no innovation in aviation comes without turbulence. Open fan engines look beautiful in concept, but they bring new headaches. Without a nacelle, the spinning blades are exposed to more drag and potential noise, and although CFM's variable pitch design helps reduce sound, getting it quiet enough for passenger service is still a major engineering challenge. Then there's certification. Regulators have never approved an open fan engine for modern commercial use. Safety testing, bird strike resistance, maintenance procedures, all of it has to be invented from scratch. It's a risky bet, but Airbus has a reason to take it. The last time the company took a bold leap, it gave us the A380, the largest passenger jet ever built. It was a masterpiece of design and a commercial failure. The market shifted towards smaller, point-to-point aircraft just as the Super Jumbo took flight. This time, Airbus is betting on the opposite. The future isn't massive, it's modular and efficient. Still, the open fan faces the same question that killed the A380. Can airlines justify the cost and complexity of something so different? If the answer is yes, the reward could redefine flight as we know it. Here's the fascinating part. The open fan engine isn't some brand new sci-fi breakthrough. It's actually the return of an idea that was too early for its time. Back in the 1980s, General Electric and NASA built something called the unducted fan. Engineers already knew the physics made sense. If you let the fan blades spin in the open air instead of wrapping them inside a casing, you can move a lot more air using a lot less fuel. In testing, the concept worked. In fact, it worked astonishingly well. The problem wasn't performance, the problem was everything around it. The blades back then were made of metal, which meant they needed to spin faster to produce the necessary thrust. Faster spinning meant more vibration, more stress, and a lot more noise. And if there's one thing passengers notice more than anything else on the plane, it's noise. So the unducted fan got labeled as too loud to ever fly commercially, and the idea was shelved, filed away as a brilliant but unrealistic experiment. Fast forward to today and things that made it impossible aren't impossible anymore. The blades are now composite, meaning they're lighter and stronger and can be shaped in ways metal could never allow. They don't need to spin as fast to produce thrust, which immediately cuts noise. There are also advanced acoustic dampening features, airflow shaping tools, and micro-adjusting blade pitch mechanisms that literally change the blade's angle to keep noise low throughout the flight. And on top of all of that, engine placement and wing shaping are now computer modeled millions of times before a single bolt gets machined. The result is something that works like the original unducted fan but behaves like a modern jet engine. The same lift and performance you'd expect from a much larger wide-body aircraft, but achieved by something significantly lighter and cheaper to operate. This is how aviation evolves. Not in straight lines, but in circles, old ideas brought back when the world finally has the tools to make them work. Sometimes the future isn't new at all, sometimes it's simply ready now. To understand why a smaller long-haul jet is such a big deal, you have to look at the aircraft that ruled the skies for half a century. The Boeing 747 really defined the era. It turned the globe into something you could cross in an afternoon. Then Airbus tried to push that idea even further with the A380. Larger cabins, quieter engines, more space, more comfort. These planes were built for a time when air travel was still an event, but the world they were designed for didn't last. Fuel got more expensive, airline margins tightened, and travelers changed their habits. People began to prefer flying straight to where they were going, instead of detouring through massive hub airports. So every time a giant jet took off with empty seats, airlines lost money. And over time, that reality chipped away at the era of the Super Jumbo. The lesson wasn't dramatic, it didn't happen all at once. The change just crept in. One retired aircraft, one cancelled order, one airline quietly switching to a smaller plane. Aviation history doesn't turn like a switch, it leans, and now it's leaning again. This is where the story shifts from technology to strategy. Boeing sees all of this is happening, but they're boxed in by their own past decisions. The 737 is a brilliant design, but it was born in the late 1960s, when engines were smaller and landing gear didn't need as much clearance. It was never designed to accommodate the kind of massive open fan engines that Airbus is preparing to test. To match what Airbus is doing, Boeing will need to build an entirely new jet from scratch, and that's a multi-billion-dollar, multi-year commitment that the company has been hesitant to make. Meanwhile, Airbus has a platform that can evolve. The A320 family leaves room for experimentation. So the real advantage isn't the open fan engine itself. The advantage is time. Airbus can move now. Boeing has to wait. And in commercial aviation, waiting costs markets. This is how an industry shifts, not because one company builds something amazing, but because one company can't move fast enough to answer it. The impact of this shift goes far beyond what airplane you sit in. It changes the shape of global travel. The old model, the hub-and-spoke system, pushes everyone through a few giant airports. Heathrow, JFK, Frankfurt, Dubai. Everyone connects, everyone waits, everyone crowds. Smaller long-range jets break that model. They make it viable to offer direct flights between cities that could never support a wide-body route. Instead of one massive flight between two major hubs, you get several direct flights between secondary cities. Suddenly, Reykjavik becomes a gateway between North America and Europe. Lisbon becomes a bridge between South America and Europe. Helsinki connects East Asia and Western Europe without the London bottleneck. The map of global travel becomes more detailed. More threads, more routes, more choice. Passengers don't necessarily notice this at first, but they feel it in shorter travel days, fewer crowds, and the simple relief of flying directly to where they're going instead of being routed through a massive hub. There's also the comfort question, and yes, a narrowbody isn't as wide as a 777 or A350. That's not changing. But what is changing is how airlines use that space. New cabin designs are shifting away from cramming in extra seats and instead are focusing on making the space feel calm and predictable. Softer lighting that shifts with the time of day, cleaner air circulation, quieter insulation, and overhead bins finally big enough for everyone's bag. Walking into a brand new A321 cabin feels completely different from what most people think of when they hear small airplane. The gap between a narrowbody and a widebody cabin experience is shrinking every year, and if your flight is shorter and cheaper, most people are happy to make that trade. Here's the grounded timeline. The open fan test flights start later this decade. Certification could well run into the early 2030s. Real passenger flights? Mid-2030s realistically. That sounds far away, until you realize the A320 has already been flying for almost 40 years. When aviation changes, it changes slowly, but then it reshapes the industry for decades. This is one of those moments, and when it happens, it won't feel futuristic. It'll feel obvious, like this was the way long-haul flying should have worked all along. So the question isn't whether widebodies disappear. They won't. The A350 and 787 will still fly the long, high-demand routes where they make sense. The question is, how many flights that used to require a widebody no longer will? So now it comes down to what actually matters. If a smaller aircraft can fly farther, cheaper, and more often, then the old hierarchy of aviation gets rewritten. Your next long-haul flight might not feel dramatic, it might just feel normal. You'll board a single-aisle jet, you'll sit down, you'll fly across an ocean, and then you'll realize the shift has already happened. So no, widebodies aren't disappearing tomorrow. The 787 and A350 will still handle the busiest, longest routes, but the industry is shifting. Airbus is showing that long-haul doesn't have to be huge to make sense anymore. This new open-fan narrowbody is really about flexibility, flying farther with less fuel to more cities without relying on big hub airports, and that changes the whole game. So the next time you see a single-aisle jet climbing out, don't just think short-haul. You might be looking at the future of international travel. Would you cross the Atlantic on a plane this small? Let us know in the comments. If you enjoyed this, like and subscribe for more stories from the skies.